Okay, we're back in calculus review. This is section 1.4, difference quotient. And we're going to find the difference quotient of functions. So this concept will be visited later in calculus. We're going to take the limit definition of the derivative, and you're going to see how this all ties in very nicely. So it's a good idea to be able to review the difference quotient. Now later on, the reason why it'll be a little bit more clear is because of limits. But the idea is that when we simplify a difference quotient, we need to rewrite it in a form where the h in the denominator cancels out. Once the h cancels out, our work is done. This is the typical definition of the difference quotient. Now there are different ways, or there's varying degrees of how it looks, but this is a very common version of how it looks. And to note a few things, we have two f functions. We have an f function with this input and an f function with this input. Remember, we're plugging x plus h into our function, and then we simplify it from there. So here's our first one. Example number 1. It gives us our f function, and we want to use the difference quotient, which is this, to be able to basically, remember I said our goal is to simplify that h. So we need to find two versions of the function. Well, I already have f of x. That's right here. It gives it to me. F of x equals 2x squared minus 3x minus 2. But now I need f of x plus h. So what I'm going to do is, remember, we have to imagine our function has these placeholders. Whatever I'm plugging in here is what I plug in here. Those need to be the same. So I'm going to be plugging in x plus h. So now I have my two elements there. I can simplify this further if I want. This is FOIL, or distributing. And so this will become 2 times x squared plus 2xh plus h squared, which is 2x squared plus 4xh plus 2h squared minus 3x minus 3h minus 2. So now I can take those values and I can plug them into the difference quotient. So we said the difference quotient is f of x plus h minus f of x all over h. So this, I'll change the color, this replaces this spot right here. And then I'll use this color. This replaces, and I'll move it here, my f of x. So it's like you cut and paste it almost. So having said that, I'm going to have 2x squared plus 4xh plus 2h squared minus 3x minus 3h minus 2. So that's my f of x plus h. Now it says minus my f of x. And that's all over h. So now that I've plugged my two functions in, now we said the goal is I have to manipulate this to cancel out h. Well, let's see if things cancel out. If I distribute this negative through, I get negative 2x squared plus 3x plus 2. Well, it just so happens that the positive 2x squared and that cancels out. The minus 3x and the positive 3x cancel out, and the negative 2 and the positive 2 cancel out. And so now I'm going to be left with 4xh plus 2h squared minus 3h all over h. The trick when it comes to standard polynomials like this is that all of the values that don't have an h in it will cancel out algebraically. They will. So if you notice, what I have here on top, I have an h in common. So I can factor out that h. And now the h's will cancel out. And so this is what I have left over. Now this is where we stop here with the difference quotient and practicing it. But once we learn limits in calculus, we're going to be able to take that to a new level. Next one, we can also find the difference quotient of square roots. So I need to find and label my f of x and f of x plus h. Well, I already have my f of x here, so let's find my f of x plus h. So remember, we said it's like placeholders. And so because this is x plus h, this will be x plus h. So now I can plug it into the formula. So my formula is f of x plus h minus f of x all over h. So plugging it in, I have the square root of x plus h. There's my f of x plus h minus my f of x. That's all over h. Now this is where it gets a little tricky, so it's like, well, how do I cancel out the h? And there's a secret that you have to remember, and I have it listed here. With radical functions, you have to multiply the numerator and the denominator by the conjugate of the numerator. So I have to multiply by the conjugate of the numerator, which means the statement's the same, so x plus h and root x, but I change the symbol. That's a plus instead of a minus. And I have to do that to both the numerator and the denominator. So now, these get FOILed together. So if I do first, I get x plus h. Outer, notice what's going to happen here. I get plus square root of x times square root of x plus h. Inner, so minus square root of x times square root of x plus h. And last, which is minus x. And that's going to be all over h times the square root of x plus h plus square root of x. So my positive and the negative version cancel out. The positive x and the negative x cancel out. And so now I'm only left with h over h times the square root of x plus h plus the square root of x. Now my h's cancel out. So I'm left with 1 over the square root of x plus h plus square root of x. And so that right there is my simplified difference quotient. Example number 3. So we're going to be doing the same thing, except now, because it's going to be a rational function, you must multiply the numerator and the denominator by the common denominator. So we're going to see what that means in a second. So first thing I need to do is I need to find and label my f of x and f of x plus h. So here's my f of x, I have that. Now I need my f of x plus h. So that's going to be 3 over 2 times x plus h. And then I still have my plus 1, which if I wanted to simplify that, that gives me 3 over 2x plus 2h plus 1. All I did is distribute the 2. So now I can plug this into the formula. So plugging into the formula, I'm going to get 3 over, so here's my f of x plus h, so I get 2x plus 2h plus 1 minus my f of x, 3 over 2x plus 1, and this is all over h. So with the rational function, you multiply the numerator and the denominator by the common denominator. Well, it looks like there's potential for me to combine these together. So the common denominator would be that this needs a 2x plus 2h plus 1, and then this needs a 2x plus 1. So, and then this needs a 2x plus 2h plus 1, and then also a 2x plus 1. Now I'm multiplying the top and bottom by that common denominator. So there's the numerator, and now I'm going to multiply the denominator by it. So 2x plus 2h plus 1, and then 2x plus 1. So I'm multiplying both of those by that. Now it seems kind of vague still, but we're going to see what's going to happen here very shortly. So now trying to simplify this, immediately this and this cancel out. This and this cancel out. So rewriting what I have left, I'm going to have 3 times 2x plus 1 minus 3 times 2x plus 2h plus 1 all over h times 2x plus 2h plus 1 and 2x plus 1. So now I just need to simplify the statement so I can distribute the 3's. And so I'm going to get 6x plus 3 minus 6x minus 6h minus 3 all over h times 2x plus 2h plus 1 times 2x plus 1. So now the 6x will cancel out with that 6x, the 3 will cancel out that negative 3, and then if you notice I have just a minus 6h left, and so that means the h's will cancel out. So my final statement is going to be negative 6 over 2x plus 2h plus 1 times 2x plus 1. So I got rid of that h. And so this would be the simplified version of that difference quotient. So in conclusion, what was reviewed today? Well, we reviewed the difference quotient. And then what I want as feedback is how would you describe the entire process of you doing the difference quotient? Okay, because I know I gave my own terminology when I did it. How would you do it? Go ahead and describe it. Well, this does conclude our lesson. If you have any other questions, please leave them in the comments.